Let's start with this number one, part A. Find the linearization of this f of x at a point one. Well, this is a calculus class. When you see a function, what's the first step?
Differentiate.
Yeah, let's differentiate that. And then you'll never be wrong if you differentiate a function on an exam. F prime of x is 5 times 2x minus 1 to the power 4. Is that it?
Inside.
No, by the chain rule times 2. Yeah, very good. Nice catch. So this is 10 times 2x minus 1 over, to the power 4. So this is f prime of x. And why is that useful? Because we want to compute the linearization. When the linearization is given by this definition, L of x equals f of a plus f prime of a times x minus a. So that's the definition of the linearization of a function at point A. This guy, the second pink box is the definition. So you've got the magic wand, you've got the definition. So what's stopping you from casting the spell? What's stopping you from using that? So let's use that. The linearization, according to this definition, is equal to L of x equals f of a plus f prime of a times x minus a. Well, a is 1, so f of 1 plus f prime of 1 times x minus 1, right? I just copied the definition, the roadmap there by definition. All right, this is L of x. What is f of 1? Well, f of x is known, so f of 1 is easy to compute. Just 2 times 1 minus 1 to the power 5 by definition of f of x. So this is 1. And what is f prime of 1? Well, f prime of x has already been computed. So f prime of 1 is just this replaced with x replaced by 1, right? Just 10 times 2 times 1 minus 1 to the power 4. Disappear. 10 times 2 times 1 minus 1 to the power 4, right? That is 10. Am I convincing? Yeah, so just 10. Yeah. Therefore, L of x has been computed. It's just 1 plus 10 times x minus 1. In other words, L of x is just 10x minus 2, minus 9. So that's part A. Is everything clear? Next, we want to use this L of x to estimate a rational number solution to this given equation. Let's call this equation star. We want to use that to solve this equation. This is kind of a new problem, like a new, pretty novel type of problem. Use the linearization to solve that. Well, the core spirit of linearization is to use L of x to approximately replace f of x. So that's the core spirit, the core value of linearization, the definition of linearization. That is f of x approximately equals L of x. That is what linearization means. We want to use L to replace f. L is a linear function, right? It's a very easy function. F is a garbage function, a nightmare. So we don't want to deal with f, we want to deal with the linear version of it. We want to use L of x to replace f. That's the core spirit of linearization. So following this spirit, what's the left side of this equation? Are you eyes sharp enough? Very good, yes. This is f of x. This is f of x. What's the core spirit? Approximately equals L of x, right? So let's use this. This is approximately equals L of x. What is L of x? L of x has been computed in part A. Yeah, so we just plug that in. L of x is 10x minus 9 by part A. Yeah. Therefore, this equation has been converted into this easier version. 10x minus 9 equals the right side, 1.1. Now you know how to solve for x, right? So that's it. Next, the star has been reduced to this linearization. 10x minus 9 equals the right side, 1.1. So let's solve for x, very easy, right? Just first add 9 to both sides and then divide both sides by 10. So we get x equals 10.1 over 10, which is 1.01. So that's the solution to this stuff. Again, the most important step is the definition of linearization. That is, we use L of x to replace f of x. By following this step, we can take a PhD problem and give it a kindergarten makeover. We've just converted this PhD problem into this kindergarten problem. And yeah, that's it. Let me show you the entire solution. It's number 1. A funny thing is, do you know ChatGPT? Cheat GPT or Chat GPT, right? Not cheat GPT. Well, yeah. This is a very good app, like very developed by OpenAI. As long as you don't use that to cheat, then it can be a very helpful tool. And this course, you guys are very lucky because this course is Calculus 1, and ChatGPT is very good at solving Calculus 1 problems. It rarely makes mistakes when you input a Calc 1 problem or any calculus problem. Unfortunately, it's very bad at solving PhD problems. It makes tons of mistakes. It's hard to imagine how many mistakes it can make. Like, they are very hard to make, but it makes all kinds of them. So just use that well. It can be very helpful if you input a homework problem, it'll immediately give you the answer. But I still encourage you to try that first. And then you can use ChatGPT to check your answers. You know what GPT stands for? It stands for Great at Proving Theorems. No, that's a joke. It actually stands for, I believe, Generative Pre-trained Transformer. That's what it means. Very serious name. G doesn't stand for giggles. It's a very serious name. It's a real deal.